Estamos ready? Sí. Good morning. Thank you for the Vueling people who's here today with me to accompany me on this brief season. I wanted to give you a brief introduction about quantum computing and what and why we are doing it at Vueling. First of all, I will introduce myself. My name is Kevin Rodriguez. I work as a developer on the Innovation Lab department, and I'm in charge of the quantum research group. So the quantum framework, what is it? We want to create a framework for our data science to abstract them from all the complexity of using quantum computing nowadays. So let's talk about the basic properties about quantum computing. So the first one is the superposition. We know we have classical bits where we can have 0 and 1s, but with qubits, we can have 0s and 1s at the same time. So imagine that in terms of compute, the power that it could be for this technology. Second, I want to talk about the entanglement. So we can have a qubit here in this room today, here hacking with us, and we can have another qubit on the other side of the world. And if we change this qubit, it will automatically change the other one. So despite of this all these cool things I'm telling you, we have the decoder. So when we try to measure these qubits, these qubits are prone to error. So they are not really good to find the result we want. So this is a question for you. If do you know what's the temperature in a quantum computer? So in which temperature are the quantum process units? Does any of you want to guess? Minus 300, okay. Someone else? Okay, so you were really close, so it's near the absolute zero. So it's minus 273.15. So why is that? Because when we have the qubit in cold state, it's less likely, so it's gonna move the material. So that's why we put it on this state. Okay, now apart of talking about the properties of quantum computing, I want to show you the marketplace. So who are the key players on this competition? And also, I encourage you to try the Amazon bracket and the IBM Cube, where you're gonna have like 3 hours to spend around and try your quantum algorithms if you want to learn on this career. So I'm going to open first the Amazon bracket. You cannot see it, no?
Yes.
No, yeah, we can, but not on the streaming. Just give me 1 second. I'm gonna ampliar. Okay. That's gonna be harder for me because I'm gonna have to look here. So as we know, Amazon Web Service, they also provide the Amazon bracket, where you can execute your quantum algorithms. Amazon bracket doesn't have a quantum computer itself. They offer simulators, but they do not have a quantum computer open for the public. I'm sorry, it's quite slow. Okay, so here you have different companies like Xanadu, Rigetti, Tuera, Oxford Quantum Circuits, and IonQ, and you can execute your quantum algorithms on these machines. So Amazon Web Service, these are the simulators, and they are available right now. But these companies are third parties where you queue your quantum algorithms to run it. So quantum computer is really fast to execute, but the thing is, if you don't have a partner with those companies, you're gonna have to wait 2 days or 5 hours or 3 days to put in a queue your quantum algorithm. So you're gonna have to wait some time. So with all the ecosystem you have, you only need the ARN in your Jupyter notebooks to execute the quantum computer. So for example, here it tells you the availability, which is on the weekdays. I suppose that on weekends they do maintenance, and how many qubits the machine has available for you to try. Also, how much do you have to spend if you want to run the task, and how many shots. What I didn't tell you before is the quantum computer is a probabilistic machine. So for your algorithms, you're gonna have to run, like, for example, 1,000 shots to have the best probability to achieve your goal. Also here you have the tasks, all the tasks we run. And I wanted to show you the Jupyter notebooks. Have you ever worked with Jupyter notebooks, or you never use them? Do you know at least what it is? Yeah? Okay, that's cool. So I tried Jupyter notebooks a couple of months, and it was really easy to write documentation and just run parts of code, as you can see here, and in the way to explain to the others. So in this Jupyter notebook, we will import the circuit and the local simulator. And what we are going to do is we will apply a Hadamard gate. And the Hadamard gate is the gate to put in superposition the qubit. And we will also apply a CNOT gate. So on the first qubit, we will apply the superposition, and on the second qubit, we will apply the entanglement. So we have the device, and on the result, we see that we run 1,000 times this circuit, and in a probability of 0 and 0, 525 times it was a 0, and 425 times it was a 1. I think you have a couple of hours in Amazon to try all this stuff, so I recommend you to look a couple of videos and try it. Also, the other big player we have here is IBM. IBM offers you a lot of tutorials. If you want to start learning quantum computing, it will be really helpful. And they also have an interactive console where you can drag and drop and create your own circuits, as I'm going to show you now. Where you have here the qubit, and every time you add, as we mentioned before, the Hadamard gate to the first qubit, we will see the probabilities that it can have before, after, and also it's writing for you the code on your right. And you can see the block sphere where you want to put the qubit to get the best out of it. And also, if you want to run the quantum computers from IBM, you just have to tell them how many shots you want to run these algorithms, and they have available for you to try computers with just 7 qubits, which is a lot to get started. And here you can also play some algorithms. I will come back to the presentation. And if I share like this. So in my opinion, IBM is one of the leaders. As you can see here, we are in 2023. They didn't release it yet, but they have the quantum computer Condor with 1,000 qubits. And 4 years ago, we only had 27 qubits. So imagine in 5 years, we might have a quantum computer with 10K or even more. We don't know yet, but it's growing exponentially. Going back to the quantum framework, we are using the PennyLane library because in Vueling we think that we don't know yet who is going to be the leader of this quantum race, even though IBM is well positioned. So with PennyLane, we have the opportunity to create our algorithms and run on a device agnostic. So we don't care which computer we want to use. So it could be working with IBM Quantum or Amazon Bracket or even Azure or Google QCS. What we will do is we will take the queue, and whichever computer is available, we will be able to run the algorithm. And okay, so I'm going to show you the last POC we did in the startup. Okay, as a developer, we want to also, on the Innovation Lab, abstract from all the complexity of quantum computers. So we built this POC with a doctor in quantum computing and a doctor in machine learning. So I'm going to share the code. So you're not seeing. So the idea was to, from a small database with quantum computers, find the best hyperparameters for training after. So having a classical model and just a tiny piece of quantum computer algorithms, and after we come to the classical world and we do our thing with STL. Where we upload the database, we focus on finding those hyperparameters, the param learning rate and the max iteration, and we give it as an input. So we create our quantum model, which is a lot of complexity which I cannot explain right now because this is done by a doctor in quantum computing. So for me, this is a black box where we transform the data into the quantum space, we train the algorithm, and then we just find the best hyperparameters. I'm not going to run the code right now because it costs money, as you could see before. And what we are creating with this, we are taking all the methods in small pieces and classes to prepare the quantum framework. So if we go to that class, classic to quantum, all of this stuff, what it's saying is that the data science won't be worried about how many qubits I have to use. So with the database we have, this method will calculate how many qubits it has, and it will add an extra qubit for every categorical feature the database has. And when it comes to, as I mentioned before, that we want to avoid being device or vendor married, or we want to be vendor agnostic, we have created an abstract factory. So when the data scientist wants to use the local simulator, he will go to the default qubit or Lightning qubit or Racket qubit, And if he wants to use the bracket, he will write just break AWS qubit. And if he wants to use IBM device, he will have to write this kit IBM. So if maybe in the future there's another team player, we can add Google or we can add Microsoft. This is something that we are working on, and we want to have it ready for the 2024. And on the Amazon bracket, I also wanted to show you that we are controlling how many qubits you are sending. So if you are sending more qubits than the quantum computer has, we won't allow to. If you are trying in more shots that the quantum computer can have, we won't allow you. If you don't create a bucket to place your results, we also won't allow you. And with that, we'll create a device, a QML object. QML is from the PennyLane library. And with this QML device, we will be able to execute our algorithm. So don't worry about this access key. It's public, so it's not the real one. So I'm not leaking any sensitive information. But just if the data scientist wants to use, so he sees that Rigetti is free and he wants to use it, he will only have to use on the .m the Rigetti AWS device and also which type of device he has. And that was pretty much what I wanted to show you today. So just a quick recap of what we have done. So we learned the basic properties of quantum computing. We learned how to get started with IBM or with Amazon Bracket. And we also learned that we at Vueling are doing cool things with quantum computing. And I also wanted to share a story for the end of this season. I was trying to learn and understand quantum mechanics like 2 weeks ago, and one of my colleagues, which is a physicist, you will know it, Victor Santiago, was telling me, what's the matter? And I told him, I don't understand anything. I'm reading over and over, and I don't know what the hell is going on. And he told me, go and check who is Richard Feynman. And he was a physicist. And I found this quote really interesting to deal with anxiety. So if you think you understand quantum mechanics, you don't understand quantum mechanics. So that's how I'm dealing with anxiety, and that's how I will go forward, because I don't understand anything what is going on with this material. Thank you very much. I hope you learned something, and good luck with your HackUPC this weekend. I don't know if you have any questions, or we can have a chat later. No?